All right, thank you for coming here. Today I'm gonna talk about my NeurIPS 2025 paper called Strategic Hypothesis Testing. And this is a joint work with Safwan and Yiling from Harvard. So before I talk about this work, I just want to give you a quick overview of my research. In general, my research lies in the intersection of game theory, machine learning, and decision making. So the type of question I think about, for example, is like how strategic human agents interact with a machine learning system, and in general, how incentive from any decision rule shapes the outcome of algorithmic decisions. And this paper fit into this theme, so hopefully you have a better idea of what kind of research problem I'm interested in. Okay. So the motivation of this work comes from the fact that actually many real-world decisions have to rely on some kind of noisy evidence coming from some statistical test when the ground truth or like when the ground truth is not observable. So an example that you can have in mind is this FDA drug approval process. So FDA stands for this Food and Drug Administration in the US. And basically, whenever a pharmaceutical company develops a new drugs, and in order to sell it to the market, it has to have FDA's approval in the beginning. And of course, FDA couldn't directly observe if the drug is effective or not, but they can ask the company to run the clinical trial, basically by recruiting a bunch of patients, give them the drug to see how the drug performs on these patients. And in this case, the FDA's decision on the drugs is entirely based on the clinical trial results. So let's take a deeper, a more detailed look into the FDA testing protocol. So essentially, what the FDA will do is they will specify a p-value threshold alpha to test the null hypothesis that the drug is actually just a placebo. And you can think of this alpha as a way to for the FDA to control like the strictness of their decision rule. A smaller alpha usually means that they require more stronger evidence from the drug company before they approve it. And then the company will run the clinical trial with potentially N patients and record the result, submit it to FDA, and the FDA essentially compute the p-value of the results based on the results from the clinical trial. And if this p-value is smaller than the pre-specified p-value threshold alpha, accept, otherwise reject. So you can think of this p-value as a way to basically to show how strong the drug is tested against the baseline. So from the company's perspective, their decision will be on how large they want their trial to be. So in general, you can imagine that the company are rational in the sense that they will only request to run the clinical trial if the revenue, once they get approved, is higher than the cost of running the trial. And overall, for any FDA's fixing rules, you can imagine like having a larger sample size usually means that your test results have more power. So it will boost your chance of being approved, but at the same time, it will cost you more. And overall, for drugs whose effective size is not too big, usually it means that you need to request a much larger sample size to demonstrate that your drug is effective. So in other words, the company usually will do a strategic self-selection. What I mean is that if they will kind of decide what's the optimal trial they should run, and if that optimal N star corresponds to a negative expected utility, they would prefer to not participate. All right, now for the FDA, knowing that the agents will do a strategic self-selection, what they're gonna do is they're gonna specify an optimal p-value threshold to minimize two types of errors. The two errors are false positive and false negative. So false positive just corresponds to you approve a drug that is actually not effective, and false negative corresponds to you disapprove some effective drugs, or somehow all the effective drugs does not participate. And in general, you can imagine these two terms are trade-off for each other. If you set the rule to be too strict, then of course, inefficient drugs will not participate, but at the same time, some effective drug will also kind of drop out. Now let's briefly talk about what the results are for this paper. So based on the modeling framework that I just described, we provide some characterization of the optimal behavior for both parties, and in mechanism design, this two-party usually refers to as the principal and the agents. So the optimal behavior for the principal in the example I gave is the FDA is to select the optimal p-value threshold. And for the agents is the optimal size of the trial that they request. And in particular, we also characterize how different loss components change as we vary the p-value threshold alpha. And interestingly, they are actually monotonic. They are monotonic function of the p-value threshold, and this is actually the same as classic hypothesis testing when we don't consider the agents doing this kind of strategic self-selection, which is kind of interesting. And in general, our results offer a lot of insights for policymakers or regulators who have to make decisions based on statistical evidence. And perhaps my favorite results from this paper is the fact that usually we think of agents being strategic as a bad thing, but in our setting, agents' strategic self-selection actually works in favor for the principal. The way we demonstrate this in the paper is that we have this proposition basically showing that for any policy, there will be a participation threshold. What I mean by that is that only the drugs with effective size greater than this policy will participate, otherwise they will not. And this participation threshold is also a monotonic function in the policy. So what this means that the principal can actually choose a stricter p-value threshold alpha in the way such that only the good agents will participate. All right, so here comes the final remark. The general message from this paper is that when you make decision based on statistical evidence, it is not only used to make decision, they also kind of act as a gatekeeper. In the sense they kind of shape who will actually choose to participate, and sometimes they will actually work in favor of you. And in general, our model can be used to study much broader settings. So basically, if let's say you're a company, you want to decide if you want to include the new features for your app, you'll have to do some kind of A/B testing, and it also kind of fit into this general framework that we provide. That's it. If you have any questions, feel free to ask.